So it's a very special occasion today, and we are, absolutely delighted to be able to celebrate the centenary anniversary of Professor Sivaraj Ramaseshan. He, I haven't met him personally. I'd never had the opportunity, but what I have read and heard about him, he has been amazing physicist from the Raman, School of Physics, Broad, and his specialization was crystallography, and then he went on to, pioneer material science in this country. He's been, of course, the director of ISC and many more. I felt that I may not be able to do justice to such a personality in fullness, and I'm really glad that Jyotsna is very happy to say a few words and introduce the personality and the occasion to us. Jyotsna.
So again, thank you very much for this wonderful occasion. If the slides can just loop while I'm speaking, that would be nice. Yeah. Sivaraj Ramaseshan's life and work was deeply intertwined with the history of science in India and with the growth of this institute and its sustained contributions as a center of excellence. On behalf of the Raman Trust, I thank Professor Sauradeep for organizing this tribute to his memory. My own involvement in the trust has much to do with people like Shivaraj and his contemporaries, and so I hope you'll forgive a rather personal note from me. I cannot remember a time when the Ramaseshans did not feature in my family life. My mother Nalini knew Shivaraj and Kausalya since her college days, when she was transplanted from Madras in 1942. Panchavati was just a stone's throw away from Orchid House on 15th Cross in Malleshwaram, where Nalini's grandfather lived. And the cosmos of the Indian Institute of Science had already gained a reputation, and the brilliant nephews of Raman were already well known. My father was a transplant from far-off Punjab, but when he joined the IISc in 1951, among the first friends that he made were Sivaraj Ramaseshan and Amulya Reddy. They remained dear friends, colleagues, and something else indefinable all their lives, involved in a myriad of national scientific and local projects. Over the half-century of their friendship, this intense friendship included agreeing, disagreeing, arguing, debating, laughing, exulting, and grieving over science and geopolitics, national life, and things much closer to home. After having spent their lifetimes physically traveling the country and the globe, and mentally coursing through the vast world of thought, through their readings, through their discussions of the scientific, political, and fictional literature, these three men spent the last years of their lives in the same little patch of Bangalore near the railway line, where they built their houses together when they retired. Although Satish was drawn away from aeronautics into science administration early in his career, and Amulya gave up electrochemistry for socially impactful alternative technology, I should be moving these along. Sivaraj stayed deeply embedded in experimental physics, albeit moving laterally to material science from the purity of abstract physics. You will hear a much deeper and more scholarly understanding of Shivaraj's contributions from Rajaram. A common thread that ran through the friendship of Shivaraj and his contemporaries, Satish, Amulya, Goku Menon, and many others, was in their complete devotion to enabling the progress of post-independence Indian science. It took overlapping and different forms, but they all worked to ensure that the best possible outcomes could be wrested from often unresponsive official superstructures. Many of Shivaraj's scientific efforts at IISc, at IIT Madras, at NAL, focused on ingenious applications of basic physics. Now, in fundamental research, no scientist will deny that there is necessarily a great deal of the self and ego that underlies the obsession with study and discovery. Creativity demands a pouring of the self into the struggle for understanding. But in many of the myriad endeavors that Shivaraj undertook, I can only discern a deep selflessness. How else does one explain the almost single-handed restoration of rigor to Indian scientific publishing in the revitalization of Current Science Journal? Just a few days ago, we met in this very hall to revive the Gandhi Memorial Lectures, a series started by Raman. Sivaraj Ramaseshan came of age in pre-independence India, and like many of his contemporaries, idolized Gandhi. I will end with a story that moves me every time I think of it. As a young student in 1939, Sivaraj was among the huge crowds that greeted Gandhi at Wardha and waited for hours so that he could slowly inch his way through the throng to get close enough to the Mahatma to touch him as a talisman. I believe that this talisman and the ideals that it engendered were surely among the deepest well springs of Shivaraj's devotion to the cause of science in independent India, for which he is justly remembered. I'm so honored to participate in this remembrance with Shivaraj's family, in this historic room where he was a familiar figure all his life. Thank you.
It's indeed my great pleasure to formally introduce the speaker of the day, Professor Rajaram Nityananda. I think almost everybody in this audience sort of know him very well, but I think on an occasion like this, it's appropriate that we give a formal introduction to Rajaram. So Rajaram had his undergraduate education in Chennai, at the Vivekananda College in Chennai. And later he moved to the Indian Institute of Technology, Madras. After he completed his studies from IIT Madras, he moved to Bangalore in 1969 to the National Aeronautical Laboratories to work with Professor Ramaseshan on problems related to optics and crystallography. In 1975, soon after submitting his thesis, Rajaram joined the Raman Research Institute, where he spent almost 25 years. And during this time, he was involved in all the research that went on in the institute, in all the different groups. And he was a person that all of us went to when we were stuck with something. And of course, he would provide his insights into whatever problem that we were working on, which was very useful. After 2000, Rajaram moved to Pune to the National Center for Radio Astronomy, the TFR Center, as the center director. And he was there for about 10 years, till 2010. And there, of course, he worked more on practical problems involving radio astronomy, such as calibration and interference and things like that. After his stay at NCRA, he had short stints at TFR Center in Hyderabad, then ISER Pune, and then he moved to the Asim Premji University in Bangalore, where he spent almost 7 years. Currently, he is a visiting professor at ICTS TFR in Bangalore. Of course, Rajaram is a fellow of all the 3 science academies of the country, and he was an editor of 3 of the journals brought out by the Indian Academy of Sciences, the journals on physics, astronomy and astrophysics, and science education. Of course, Rajaram is a very inspiring teacher, and I am sure a lot of innumerable number of students have benefited from his lectures as well as their personal interactions with him. So Rajaram, may I invite you to give your lecture?
Thanks, RRI. Thanks, Tarun, Raghu, for this opportunity to revisit a very exciting phase of my own life and work. I don't know whether I should thank Jyotsna for, for such a marvelous introduction to Professor Ramaseshan. So there could be some overlap, but I think her perspective and her way of putting things was unique. So a lot of pictures of Professor Ramaseshan have already been shown, but here is a standard one. And the remarkable thing is that over a very long period of time, this is what he looked like, right? So I simply couldn't place where it was taken. So I searched the archives for a picture, preferably from his bachelor days, in which he was not so formally dressed. And again, that picture has already been shown. Here it is. Okay. So I think he had about a few hours of bachelor life left. And this, not more. I think nowadays you write a scientific paper or anything, you have to do full disclosure of. So in the interest of full disclosure, you've already heard I was Professor Ramaseshan's graduate student. And the interest of full disclosure, the young woman sitting beside him has fed me a countless number of times. Okay. In spite of which I will try to step back and give you a somewhat more objective view of this remarkable person. Okay. Now, it so happens that another love of his life was the journal Current Science, which you heard about. And the love has been reciprocated. In the October 10th, 2023 issue, on which the ink is not yet dry, there is an article by Balram, which I'm advertising a preview of it, or you can read about his contributions to current science. He's confined himself to that. And when we were sitting, we realized that we shouldn't really write anything else because there's so much already in current science, written at the time of his 80th birthday and soon after when he passed away. So we just collected those. And but if you're going to read only one of them, I would recommend the last one. Okay, it's written by Kausalya and gives a completely unique perspective on their early days. Okay, so let's start with a kind of bald recital, bare bones. So first class, first gold medal in BSc Honours from Nagpur, where of course his two brothers Chandrasekhar and Pancharatnam also passed through. Joins Professor Raman in 1943. And then it seems to take a long time, right? He joins in 43 and he gets his first proper degree in 51. Now, partly that's because the Indian Institute of Science itself did not award degrees, right? See how things have changed. Pretty soon they'll be handing out high school diplomas. But in any case, the other reason is that he worked for a DSc, which involves substantial, original, unguided, independent work, right? So, and therefore, my guess is that his appointment to the faculty actually might have preceded the DSc. I haven't checked. And he started guiding research students. I mean, so I have abbreviated some of the first batch of students to VVVM. And somehow he seems to have managed this repetition of letters. We'll see the pattern. So these are Vishwamitra, Vijayan, who was actually Vishwamitra's student, but part of the same group, Venkateshan, and M is Manohar. And the four became the pillars of X-ray crystallography in 4 different departments of ISC. Vishwamitra in physics, Venkateshan in organic chemistry, Manohar in inorganic chemistry, and Vijayan in molecular biophysics. So how is that for a placement record? Okay. I'll be telling you more about some of the work which happened in this period. But then in 1962, he moves to the physics department. And then for the first time, he teaches large undergraduate classes, and they are completely thrilled. There are, I think, at least one member in the audience who can testify to that. He also galvanizes the physics department, hugely networked. I happened to go there 3 years after he left, 1969. I could still see some of the impact that he had, people telling me about what his presence there was like. There was a period in the middle of his IIT stay in which he spent a year, I think, at Oxford in the laboratory of Dorothy Hodgkin. I've also mentioned an earlier very influential stay, 1954-55, in the Polytechnic Institute of Brooklyn, and both are with renowned crystallographers. You might not think of the Polytechnic Institute of Brooklyn as, a major institute, but I think that was a period where people went out from the US to great places in Europe, came back like Prometheus, bringing the fire, in this case of crystallography, from Bragg's lab and planting it in the US. So Franklin himself was like a Bhishma of crystallography in the US. Everyone else sort of sprang from him. And Dorothy Hodgkin, of course, is a legendary figure. But interestingly, in this period, he had to actually look after that group to some extent because she was away for part of that period. And he even had told me a couple of interesting stories of how he was able to debug some research student who was completely stuck and so on. In any case, IIT stay seems to have been relatively short. Okay, if you subtract that 1 year, perhaps it was the call of doing something for the nation, even if it was sort of labeled as applied physics, would have been part of the reason. And I'll have a lot to say about the NAL period. So here, let me just say that apart from the attraction of NAL, there could have been a certain element of repulsion from IIT as well, right? Right. But in this long NAL period, he does many other things. RRI went through this transition from the Raman era with a tiny number of people, a dominant figure, no government funding, to its current form. And he oversaw that transition. It's a story in itself. But some of the people who are mentioned, like M.G.K. Menon and so on, had an important part in it. In 1973, there was a consensus that the Proceedings A was not the best vehicle for all the physics happening, right? That was modeled on the Royal Society Proceedings A. So he undertook, he was the first editor of this journal called Pramana. Okay, it's a new venture that time, took up a lot of his time and energy. And he was an NAL and I was his student at that time, so I witnessed it. Then we have the period as the deputy director in ISC. I'm pretty sure this was the first time ISC had a deputy director, but again, I could be corrected by people who know the history better. I think it's a measure of his stature that someone of the stature of Satish Dhawan brought him in that role. And those of you who know Satish Dhawan will know that the friendship had nothing to do with it. In fact, he would have ensured that absolutely the right procedures were followed to bring in this person. And equally, when he had this period as director, I got the end date wrong. It's 81 to 84. It was again a relatively short period. He brought in many outstanding people. He tried to change a few things, but it's a very large system. And I think the task of shaking it up was left to his illustrious successor, Professor C.V.Raman. But in any case, in the same period, he, having handed over Pramana, he took on overall responsibility for all the journals of the Academy. He was the first person appointed as overall editor of publications. And he would always quote Raman as saying, "Do not let those publications of the Academy die." And he did not. he became the president of the Indian Academy of Sciences. And I do remember, in fact, attending some of these meetings where he seemed to know everyone. There was a little ceremony which has now gone out of fashion of the president introducing individual members, and he could really introduce them straight from the audience, right? So remarkable. And then there's current science, which was a major preoccupation with him, because current science existed from the 30s, right? And for a long period, C.V.Raman, was looking after it, but it had kind of declined, and there was a concerted effort to bring it, because it's pretty different from any other journal. I mean, though it's housed in the same building, it's not an academy journal. It has a much broader catchment area, a much broader group of editors and contributors, much broader range of subjects. And he somehow felt that this is very important. And I think those who want to know more should certainly look up that article by Balaram in the current issue, because Balaram himself worked closely with him and carried the mantle for many more years. Okay. And there's this period after that where he came to this campus, and I'll be saying something about what he did in that period. Okay. But no talk on Ramaseshan can leave out Raman, obviously, right? So the first problems he was given was to study the Faraday effect. So you already saw pictures in Jyotsna's presentation of these huge magnets and him peering down. So the idea is that you place some substance, and this is discovered by Faraday. It's a remarkable, the first proof that there was some connection between electricity, magnetism, and light. So the polarization of light, which we will talk about more later, turns as it goes through, and Raman probably had this intuition that will tell you something interesting about the substance. But independently, he was also asked to study diamond. Okay, and if you look up his papers from that period, there are quite a few papers on the growth forms of diamond and so on. Okay, no hint of X-ray crystallography at that point. Okay, then he stays on, and then clearly he moves into X-ray crystallography, as you saw from the timeline that I gave you earlier, right? And here he has a very significant overlap with G.N. Ramachandran, who's again a giant figure in crystallography, biophysics, and so on. GNR centenary was last year. Okay, so, and literally as far as joining Raman was concerned, they were just 8 months apart. Okay, so they were really colleagues as graduate students. And so before I come to his later interactions with Raman, maybe I should mention this interesting fact that GNR joined only 8 months earlier, but he finished his DSc in 1947. And the other difference, I mean, clearly Raman knew that he had two very brilliant students, but he seems to have treated them very differently. So many of the papers are with Raman, the ones written by Ramaseshan. Not a single paper by GNR is co-authored with Raman, but every one of them thanks him, not starting from the very first. So, well, I think that was his reading, right? I mean, not that he rated one better than the other, but so it's just that that's the way he did it. In later years, of course, Raman already got into this lattice dynamics controversy while he was in the Indian Institute of Science, and it turned out that in spite of his powerful intuition and experiments, he was not correct. And Ramaseshan knew this, but he did not try to persuade. And later on, again, Raman had his own views on color vision. But the important point is that in that period, he was one of the few people, when Raman himself grew increasingly isolated. This is in the 1960s. Ramaseshan was one of the few people who kept in close touch with him. Okay. In 1978, he gave a memorial lecture. So I think after 3 decades, IISc decided to have a memorial lecture on C.V.Raman, 3 decades after C.V.Raman walked out of its doors. And I really remember this. I was in the audience, and it began in a very amazing way. I think people were expecting some kind of hagiography. Certainly there was a lot of reverence, a lot of respect for his brilliance, but his opening line was, if Chandrasekhar Iyer had followed the two-child norm, the world would have had C.V.Raman, but it would not have had this speaker to talk about him. Okay? I remember that amazing opening line. But apart from bringing out Raman's brilliant career and achievements, he actually stepped back, right? And for example, he described him as a supreme egotist. Now, that's a strong word. And then if you take, again, another beautiful sally was, he remarks that at some point he decided to abbreviate his name from Venkatraman to Raman. And he says he must have known that the world will never talk about the Venkatraman effect, but it'll only talk about the Raman effect. Okay? So sallies of this kind, but serious moments when he talked about this period of isolation. He compared him to figure Timon of Athens. That lecture is available to read. And if you know your Shakespeare, that's not a compliment. It brings out a man in agony and desperation. Okay. So that was his memorial lecture where, and then in his period in RRI, I myself remember, he would constantly be working, editing 6 volumes of C.V.Raman's collected papers. Okay. And that was a mammoth task, some 400 papers. And of course, he also had this way of roping in a lot of people into it. He would, of course, be the central figure, but if he wanted someone to discuss a particular paper or even to co-author a preface to one of the volumes, he would rope in anyone. Of course, again, there were pictures. He also brought out a pictorial biography. So definitely, it's very clear that Raman was a very major figure in his life. But it is not parochial, because if you look at his investment, they were in these institutions which Raman founded, but which ultimately are part of the national scientific scene, whether it be the academy or current science or this institute. Okay, so that is Ramaseshan and Raman. Okay, I won't say more about current science, but let's just stand back and look at his publications. I don't think he would have forgiven me for this scientometry. I don't think it's a discipline that he approved of, but it's a nice kind of summary. Okay, a different. So this is the field in which he started publishing, magneto-optics and optics. So you can see a steep climb up to about 54, 58, something like that. All right. Crystallography takes off a little more slowly, and this is, of course, the period where crystallography really takes off, right? Up to, where all these brilliant people worked for him and so on. And then this is sometime around 1969, you see these curves flattening, some kind of disaster. Maybe it's because I joined him as a research student at that time. But actually, that's also the period where he moved to NAL and got into a completely new discipline. Okay, and in their discipline, you didn't publish papers. I mean, you could, but the whole idea was to deliver products, right, to the people who wanted. And I'll say more about that. But in any case, you also see solid-state physics now, a new frontier opening up. And then finally, this one, which is called miscellaneous, is mostly in current science. And there, he took it upon himself to keep track of new developments, write about personalities, write about his views, and that clearly shows what was his preoccupation the later period of his life. Okay. Now, I'm going to inflict 2 themes on you for the simple reason that he would inflict them on anyone who would listen. So one of them is the Poincare sphere, okay, and that has to do with the polarization of light. So as a physicist, I'm entitled to some hand waving. So if this is some light traveling towards you and you are an electron, the light could shake you like this or like this. That's called linear polarization, or any direction in between. It could also shake you like this. It could shake you like that. Those are the different polarizations of light. Okay, and you might wonder why a mathematician like Poincare was worrying about it, but he was an amazing person. He was trained as a mining engineer, incidentally. So clearly, he decided that he would learn optics, gave some lectures, and in passing, he found this beautiful geometric representation. in which these two circles were on the two poles of a sphere, and all these different directions were on the equator. And I won't tell you more about this Poincaré sphere, except that it hardly has a paragraph in Poincaré's lectures. People forgot about it until Ramaseshan revived it. He encountered this problem because when he was working on this Faraday effect, where this polarization turns as the light traverses the substance placed in the magnetic field, it could also turn for other reasons if there was some slight strain, and you had to separate these two effects. So you could either write a lot of algebra or you could do some beautiful geometry on the sphere. So by his own account, he talked to G.N. Ramachandran one evening, and GNR came back the next morning with a beautiful geometric solution, because they worked more on this, and they wrote it up in papers which appeared in the Journal of the Optical Society of America. And this seems to have caught the imagination, the revival of the Poincaré sphere, because very soon after these few papers appeared by Ramachandran and Ramaseshan, they were invited to write a review on all of crystal optics for a very prestigious publication called Handbuch der Physik, which of course used to be in German in the war years, in the years between the wars. And anyone who is anyone has written an article for the handbook. It is Pauli, Bether, Sommerfeld, you name them, they all wrote for it. Okay. After the war, of course, its prestige declined a little bit, but it was still a major task. It took them quite a while, because by then GNR was in Chennai and so on. But they wrote this article. All right. Now, even while they were writing this article, C.V.Raman told them that my student Pancharatnam, Ramaseshan's youngest brother, will change the subject by the time you have written the review. Okay, but they solved this problem by constant discussions with Pancharatnam. Okay, and they have included Pancharatnams in this work. Now, there is a remarkable result called the Pancharatnam phase, which I will not go into, except it's a counterexample to what Ramaseshan said. The whole world doesn't talk of a Ratnam phase, it talks of a Pancharatnam phase. So they've learned to pronounce this long Indian name because it's such a remarkable result. And I'll tell you why it is remarkable. Okay. In this institute, in the 1980s, there's a flourishing journal club. I'm really happy to see many of the people who contributed to the journal club, and Bala in particular, who kept us all pumped up to present in the club. So in one of those, Sam, who is here, and Shukre, who alas is not here, presented what was the hot topic in quantum mechanics, something called Berry's phase. Okay, and Ramaseshan was in the audience. He, in fact, has written about this later, and he says, I'm well known for sleeping in the journal club, right? And the other remarkable thing is he could sleep with his eyes slightly open. Okay? That's well known. So, you never know. But of course, he would still probably ask questions at the end of it. But I'm using the word woke up in both senses. Somehow, he felt that all this fancy quantum mechanics is closely connected with this result of Pancharatnam. Okay? And I think we were all skeptical initially, but he suggested that I should look into it. So I went forth and multiplied. Multiplied means I just multiplied a few matrices. That's all I had to do. And it became very clear that the Pancharatnam phase was an earlier and perhaps even more general version of what people were talking about in quantum mechanics, because fundamentally it's a mathematical phenomenon. Okay. So I've just put up that instant paper which was written for Current Science. So we thought we were popularizing Pancharatnam's work, but later on Berry wrote a paper popularizing this paper, and that's perhaps more widely cited. I don't blame him, because this was written in a hurry. But what's perhaps more important is that many people here, Sam, Bhandari, and others, took this concept much further. Okay, so that was the Poincaré sphere. The other topic, so I've divided into two parts, like Bahubali, the beginning and the conclusion. Okay, so is anomalous scattering. Okay, anomalous is in quotes because it's actually a perfectly general and natural phenomenon. but in X-rays it was considered anomalous. Okay. Now for that, little background. So in X-ray crystallography, a beam of X-rays goes through the crystal and you get a whole lot of spots. Okay, and each spot tells you something, if you want to think very physically, about a set of planes in the crystal, which make equal angles to the incoming and the scattered beam. If you want to think a little more mathematically, instead of a equally spaced set of planes, you think of some kind of wave. Okay, so it became popular and useful to think of a crystal structure as made up of waves. Unfortunately, how to align these waves relative to each other to build up the atomic peaks required information which was not available. The spot only told you the strength of the wave. It didn't tell you exactly where it was located. And that is called the phase problem. Okay. Now, it turned out that to a very good approximation, the scattering by any atom was just proportional to the number of electrons. Okay. And as I'll show you in the next picture, it means that if you have an incoming X-ray and an outgoing X-ray and you have a crystal and you flip it around, it won't make any difference. Okay. However, there's a very insightful paper. Incidentally, if one joined NAL, very early on, you were given a book called Optical Principles of X-ray Diffraction by James. And all the students whom I'll tell you about would have read that book. So this is a very classic experiment where they put a crystal of zinc sulfide and flipped it around, and the intensity of the scattering did change. And of course, they knew they were looking for it. And the reason, which will be clear in the next picture, is that apart from the geometrical distance between the different planes, when the wavelength of the X-ray matches the excitation of a particular electron in a particular atom, then it's as if the atom holds it back for a little while. There's a kind of delay. So, so that is this phenomenon called anomalous scattering, because it wasn't realized at first. So here is I think the yellow is supposed to be a plane of sulfur atoms and the other is a plane of zinc atoms. Incoming X-ray and a small amount going back. Okay, and the extra path between these two is, you think of this as the clock. So the sulfur, whatever comes back from the sulfur arrives first, and whatever comes back from the zinc arrives later. Okay. Now, if you flip the crystal around, of course, zinc arrives first and sulfur arrives later. But if you're only going to look at the intensity of the X-rays, it doesn't make a difference. So that is the reason for what I told you earlier, that in a simple approximation, flipping the crystal around doesn't make any difference. However, if the zinc atom decides to hold the X-ray back for a little while, then this is what happens in the first figure, right? It's delayed. But in the second figure, this is what happens. And now you can see that the relative angle between the zinc and the sulfur is different after the thing is flipped around. So the bad news is that you now have to correct for this effect. The good news is now that you have double the amount of information that you had earlier. Earlier, these two numbers were the same and now they're different. Okay, and this revolutionized crystallography. Okay, although this experiment was in 1930s, it was taken up by a Dutch crystallographer called Bijvoet. You had to learn how to pronounce his name properly also if you were part of NAL. Now, absolute configuration might seem a very recondite term, but it can be a matter of life and death. Since many biological molecules come in right and left-handed forms, right? For example, right now I'm pumped up with levocetirizine to prevent me from sneezing during this lecture. And if it had been the other one, I would have probably fallen asleep. Okay. So absolute configuration, and believe it, until this technique came along, people couldn't really tell the difference. They were guessing. Okay. So that was one contribution. But then a few years later, many people realized and listed the classic papers, and one of them is Ramachandran and Raman, a different Raman, S.Ramaseshan from Madras, that this almost solved that phase problem. So crystallography took a giant leap forward. I put the Ramaseshan paper in brackets because he himself was quite modest about it. He said Ramachandran applied it to the non-centrosymmetric crystals, whereas we applied it to the centrosymmetric crystals. Okay. And now the great triumphs of X-ray crystallography, like the ribosome, which has 100,000 atoms. I mean, that's mind-boggling, right? Considering the subject started with sodium chloride. Okay. And and the key elements are this phenomenon of anomalous dispersion, and of course a powerful source, synchrotron radiation source, which can also be tuned. Different atoms can light up. Now, Ramaseshan himself looked at different aspects of this. He realized quite early that this will also happen with neutron scattering. Okay, so and then he'd moved to NAL by that time. Singh worked on that for his thesis in, I think in all three places. I think Singh was in ISC as well as IIT, and later joined NAL. And then Vishwanathan was again one of Raman's theoretical students from this institute. They followed up. Ramaseshan always described anomalous scattering as the thin end of the wedge. So he would use it to enter different fields, right? So inelastic scattering, so where you sense the motion of the atoms, or disordered scattering, where it's not in a neat array. So a lot of work came out of this kind. And then he moved on to apply this to some interesting phenomena where it's now electron scattering of atoms in a solid, where again this phenomenon of resonance of their being tuned to a particular energy has some interesting implications. So now we come to the material science division of NAL, and of course that's the period where I have the maximum first-hand knowledge. Okay, he was there in 1966. I joined in 1969. So he moved from IIT Madras. NAL was looking for a director because the previous one, Neelakantan, was also Raman's student, by the way. He passed away quite suddenly, and the offer finally went to Sitaram Rao Valluri, who was in the aeronautical department of the IIT at that time. But I think he had earlier passed through ISC, so he and Ramaseshan knew each other. Okay, and once Valluri moved, he invited Ramaseshan to come and start from the ground up and set up this material science division, and gave him a free hand. And I think in my opinion, this was a very exciting phase of his life. He was reinventing himself. Of course, in the entire period earlier, he was not a narrow-minded crystallographer. If he studied something, he would know all about his biological applications, engineering applications, and so on. But now was a chance to actually use all that knowledge and to lead a group from the beginning, build it up from the beginning. It certainly makes a difference. Both in IIT and in ISC, he came into a group which was already very well established, and that can have its limitations. I mean, as a side remark, my own experience and observations tell you that large institutions tend to reject transplant, right? But that doesn't apply to RRI, by the way. It's not that large. So Tarun, don't worry. Yeah. So and since I spent a summer there, even before joining, he had this physics student from IIT Madras, but he said, go out and see all these exciting things which are happening. You want to cut a very hard material, you don't need something harder than it, but you can strike a spark on it, or you can erode it with electrochemistry. So machining, ISRO wanted perfect surfaces, right, to reflect solar radiation away from their delicate things. If an aircraft crashed, the parts would come to the materials division to see why it failed, right? So all these activities, I'm not saying he did all of them, but he attracted people who could do all these things. Okay, there was an X-ray lab and so on and so forth. And the important thing was there were these projects which served external users. Okay, and that was, and then he had this group of research students. So in the same notation, I've called it RRRR. Okay, so he used to describe this group as his secret vice. But there was no secret. We were right there and we were mingling with everyone, and we were doing the kind of problems which he set us, but in no way were we isolated from all the applied research going on. Okay, so again, it's interesting to see how he gave each of us a different problem. So Ranganath was the first to join, and I think in each case I can tell you a little bit about the circumstances, because I recently connected with Ranganath and Ramesh Narayan. So Ranganath apparently saw an article in the Hindu on Ramaseshan, He was already teaching in a college, and then he went to his teachers in Central College, Professor Subramaya and Professor Narasimhaya, I think, R.L. Narasimhaya. And they told him, yes, of course, you must go and join Ramaseshan. So he joined Ramaseshan. Okay. He was the first. T.G. Ramesh was an MSc student in Mysore. Okay. And he told me recently that he just wanted to finish his MSc and go and become a teacher, college teacher. But I think his teachers, which included S. Chandrasekhar of liquid crystal fame, and D. Krishnamurthy, both of whom were Raman students in this institute, and then they went to Mysore. They told him, no, you will even be a bad teacher unless you go and do some research. And there's no better place to do than NAL, go there. Okay, so Ramesh went there. In my case, it was slightly more complicated. I think, how am I doing for time? Yes, I think I certainly can tell you this complicated story. There's an element of nepotism here. Nepos stands for nephew. I'm not Ramaseshan's nephew, but I knew his nephew and two nephews and a niece very well in Chennai. I was constantly in and out of that house, and therefore that's how I got to meet Ramaseshan for the first time. And I was in my final year in Vivekananda College, as you just heard. So I invited him to come and give a lecture, and he gave a stunning lecture on plasma physics, right? I mean, that's when I first learned about the Debye length and so many other things, and even to think of a metal as a plasma and so on. Absolutely charismatic lecture. And then in a completely different context, there's this venerable institution called the Theosophical Society in Adyar. So if you give a lecture there, the average age of your audience will be well into the 70s, which would have been a big joke earlier, but now I'm in that range, right? But at that time I was young, so I was surrounded by all these very grey people. And what does he lecture them on? The Doppler effect. This is the first time I heard the concept of Fourier series, autocorrelation function. So, I mean, he had this gift of putting across any theme to any audience. Okay. So then I had a scholarship which required you to spend the summer somewhere, and I wrote to him, and I spent the summer in NAL. It was quite exciting. I saw all these interesting things, and I knew I had to find a good place to do my PhD. And again, because of this personal connection, I got a chance to go to his home, as I told you. And the crucial thing happened in one evening. So I was there, and Professor Amulya Reddy, whom you heard about, was also there. And I asked Ramaseshan, see, I've applied to the Indian Institute of Science and so on. What would be a good thing to take up there? So very carefully, he told me about each member in the Indian Institute of Science, what they are doing. And he said, yes, this is very interesting, this is exciting, so on. That's it. Okay. So then, of course, I have a dinner. And it's not a trivial fact, because there was a dinner waiting for me in my aunt's house where I was staying. I had that too. Right. And I got a lift to my aunt's house from Professor Amulya Reddy. And the moment I was out of the house, he told me, you idiot, why don't you work with Ramaseshan? He's not going to, advertise himself, but this is where you should work. And I later on learned the history that he himself wanted to work with Ramaseshan. At that time, probably Ramaseshan was relatively junior in the physics department. Let me see if I can find the right euphemism. The physics department was very culturally homogeneous, and they were not, and they were not ready to have Amulya there. Anyway, of course, Amulya did well. So then, of course, very clear, I wrote to Professor Ramaseshan, right? But no reply. So then I applied to ISC, attended the interview and joined. I'd also applied to TIFR, attended their interview, and I joined them. I didn't tell ISC that, I just disappeared. Okay. And then I got this letter after a month or so in TIFR. And it said yes. And of course, he was away because that was the summer in which Pancharatnam died. He had to go to England and sort out everything. So I got a train. I was working for a Professor Patankar I was in his lab, a diffusion lab in TIFR. I was going to just grab the next train, so I wrote him a note, right? Left it. And then I happened to meet him waiting for I was on my way out and he was on his way in the bus. So I told him, And I think it says a lot for him. And it says a lot for Ramaseshan, the reputation. So when I told him this, he said, yes, you're going to a very good place and you'll work with a very good person. He patted me and sent me on my way. So on September 5th, 1969, I landed here. So anyway, that's how I joined. And now what about Ramesh Narayan? Now in his case, he didn't need any introduction to Professor Ramaseshan because he was the son of G.N. Ramchandran. And again, it tells you something, right? I mean, you can be sure that Ramesh got a gold medal in his MSc and so on. And yes, yeah. And he could have probably gone anywhere. And it's my surmise, which Ramesh confirms, that his father advised him of go here because this is where you will learn a lot. So each one of us had our problem. So Ranganath was given a Poincare sphere and he took it and ran, right? Worked on a lot of optics. Ramesh, of course, anomalous scattering. And I was initially set on dispersion, right? So I must be one of the few people here who has actually evaluated this integral which relates the real and imaginary parts of the refractive index. Actually evaluated it. I mean, I'm raising my hand because I had to use a facet calculator and keep turning it, okay? But then a major thing happened. So this is, the kind of graduate school we all went through. And there were some remarkable people, apart from the people who were, permanently in NAL, who were also very remarkable. So S.K. Rangarajan is a brilliant electrochemist, mathematician, so on. He had a Homi Bhabha fellowship and he chose to do it in NAL. And I think part of the reason may also be that Ramaseshan had already raided the Central Electrochemical Research Institute in Karaikudi and brought over some of their best people to NAL. But it was a great gift to people like me. And I think I use the word guru in all senses. I mean, I've slept so many nights in his house and his interests were far wider than what people know about electrochemistry and so on. Then, A. J. Raman, who did his PhD in this institute and was a staff member with Raman until about 1960, then became a very distinguished high pressure physicist in Bell Labs. I mean, you can't have higher pressure than in Bell Labs, right? And then he chose to spend an entire year in NAL. And well in advance, people started making preparations. NAL, of course, had a fantastic workshop and to make a high pressure apparatus. And believe it or not, I actually moved on doing a little bit of experimental physics in Jayaraman's lab. I wasn't the only one, okay? But equally important, he brought samples. He brought samarium sulfide, all kinds of things which showed strange properties. I was given a bar of chromium, not a huge bar, a tiny piece. It's good enough. And because it's antiferromagnetic and so on. So we also learned a lot of modern solid state physics, okay? And of course, once Jayaraman was there, he could bring in other people, his Bell Labs friends who would come in for a few days, give lectures and so on. So NAL was like a water hole. I mean, visitors. So if you want to know solid state physics, today you would pick up a book by Zeeman or by Ashcroft. Both of them visited NAL. And it's not just visits. If they were sent to Mysore, some of us were sent along with them so that we could keep talking to them on the way, okay? And Nobel laureates. But the beauty is Ramaseshan seemed to pick future Nobel laureates. I checked that when they visited us, none of them had a Nobel Prize. Okay? Kapitsa, Goodenough, Dijen. And again, they would actually, I have been rebuked by Kapitsa saying, why are you measuring the thermoelectric power of chromium? Haven't you heard of Wiedemann-Franz law? Right? Because it's a metal, it'll have a very good thermal conductivity and won't be very good. But I had to tell him that I'm studying it for its own sake, not for, building a device. Goodenough and Dijen both sat down with a notebook and said, okay, what are you doing? And then wrote down their thoughts. So it's pretty amazing kind of experience that all of us had. And if someone didn't come to NAL, they came to IISc, there was no problem. Ramaseshan's name opened all doors in IISc, right? I think many people in the IISc physics department thought that I was a member who was absent most of the time, right? And of course, in the Bangalore of those days, one could cycle down. Lectures, conferences. So I do remember listening to George Sudarshan and Michael Fisher. I think both of them have a grouse that they did not get a Nobel Prize, but that's a different matter. Okay. And exposure to all this exciting projects going on. And Ramaseshan didn't hold us back from those. people would come and talk to us, and if you could contribute to it. But I particularly remember one day he came and told me, "Do you know what a Fuller dome is?" I said, "No, I don't know what a Fuller dome is." He was referring to Buckminster Fuller. He said, "Okay, you read this, and we are getting into a project to build what is called a radome. Okay? A radome is a radar dome." So he said, "Look, if you say you understand crystallography and icosahedra and all that, you please calculate the dimensions." Of course, for the icosahedral, it's easy. They're all equilateral triangles. But if you want more panels, then the triangles can no longer be equilateral. And I should tell you something amazing. We first did a 12-foot for the meteorological department. And I was asked to calculate it. And I actually got one of the triangles wrong. Okay. I mean, go ahead, correct it. So, I mean, the people who cast the mold and made the thing must have been pretty upset. But he shielded me from them. And then I was interested in calculating all these. I think this time, I think I got it right. But there was a lot of suspense because this thing is assembled ring by ring. Okay. And until you put the capstone on top, it doesn't look like a sphere. It sort of flops over. Okay. So everyone thought I'd got it wrong this time. But finally, they put it on top. Okay. And it's not just the geometry. He said, "Look, Air Force wants to know the wind loading or how much radar waves will get through." So he gave me technical reports and so on. Okay. So remarkable engagement with these things. And little did I know that I'd have to worry about wind loading and so on when I went to JMRT many couple of decades later. Okay. So time to look back on what you've heard. We are talking of a very strong, very broad physicist. And what everyone has told me and what I've witnessed myself, very powerful intuition. Okay. I suspect it was also backed up by a lot of study, a lot of working out, certainly in the earlier years when he had the time. But he wore it very lightly. Okay. A commitment to the legacy, but as you've already heard, not just the national science community, but the nation itself. Okay. A very strong influencer. I mean, that would be the word today. I've already told you of his influence on students, but of the schools which he sort of started, and they've multiplied in their own way in optics and X-ray crystallography. But also strong influence on his peers, I would say. And here, I think you've heard the story from Jyotsna. There was this group of people who could work together in spite of their differences. And of course, she did mention also the brilliant family, right? Which from the outside might have looked like a monolithic group of cousins and so on. But they were all brilliant, like the Bernoullis. And like the Bernoullis, they didn't always see eye to eye with each other. But in any case, in all these fora, I think of him as playing the role of a peacemaker. Okay. And at the end of the day, he didn't want, and at least on one memorable occasion, he advised me to go for peace, and I wish I had taken his advice. Anyway, he had plenty of honors and positions, but he's not really about those. And because you can find others who probably had more. Okay. It was really about his direct influence by example, what he did and what he was. And I think that's what we'd all like to remember. Thank you. Yes, if we can, yes.
So in case there are some questions relating to what Rajaram talked about, or some comments?
Quick clarification. You mentioned the name Mani. Does it have anything to do with the money we know of? HS Mani? No.
No. He's a crystallographer for money, not HS Mani.
Oh.
No. NV Mani. Oh, you know that? Oh, HS, yeah, right. Yeah.
Thank you, Rajaram. It's a wonderful account. I would like to add, Professor Ramaseshan was looking how to build institutions. And in 1 year, when he was associate director, he brought T.V. Ramakrishnan for solid state physics, condensed matter physics, and Rajaram for computer science, and myself for cosmic crystal cell persistence. So he was always a builder of institution. He was not looking for anything personally himself. And I think his contribution from the Oxford Dorothy Crawford Hodgkin is something I'll always remember. He came to Benares, accompanying her, and along with G.N. Ramson's son also. And at that time itself, I can see he was not looking for honors for himself at all, but wanting to build institutions, build individuals, and make things good. I think no words are too much to give in honor of Professor Ramaseshan. We create homage. Thank you.
Yes, I glossed over the ISC period a little too quickly, and even in that short period, he did bring in many outstanding people.
Okay, if there are no other questions.
Just to say that I had the luck of being shown the handbook Dirt Physics, which contains his article with GNR, and also told me about how to read about that. And then he also showed me that S. Chandrasekhar has written the same, in an inequality of Stokes parameters in the other book. And it was wonderful talking to him after reading those also and going back to him and discussing.
By the way, that was a different S. Chandrasekhar.
Okay, I just wanted to mention about an amazing lecture by Ramaseshan, which I heard when I came to attend a summer school in RRI. So he gave a lecture on Newton's optics, and I remember that I almost don't remember about any other lecture in the summer school, but that lecture was so amazing that I still remember. And I don't know whether Ramaseshan ever wrote it up or anything like that. Also the contents of Newton's optics and it's a historical context and things like that. And also, you did not mention another thing, that Ramaseshan was the founder of this joint astronomy program when he was the director of IISc. But for whatever be the reason, he was, afterwards, he was not so enthusiastic. When I was thinking of taking up a job there, he tried to discourage me that there are lots of problems with that program, don't join that. But anyway, I did not heed his advice for good reason or bad reason. I joined that. And after he came, he was always very kind to me. So he did not hold it against me that I did not listen to his advice.
So, do I take it to mean that you do not remember the two lectures I gave in the same summer school?
In this great occasion, I would like to share with you all. Really, I had a good opportunity with Professor Ramaseshan 1 month time during Bose centenary conference at Calcutta. For that, myself, Smiles, and Professor Ramaseshan, we used to work, and through him only I got to learn quasi-optics diplexer, which we later used for our millimeter wave observations. And one toughest problem he gave me, in fact, we made a multiple experiment in a single plate. He asked us to do it. It was published long time back. And the jute experiment, he wanted to do it. And Teflon, the waste Teflon in the lab, we used to make the lenses of Teflon. We used to bring it, and the jute, and all those experiments. And really, he's a great person. I was happy as a lab assistant to work along with him for almost 1 month around the clock. I'm happy to share this.
So, I'll just add, this is the J.C. Bose centenary, right? And reproducing his experiments. Great. I'm learning things I did not know, actually. Yeah.
J.C. Bose time.
Right.
I want to give a very, sort of very much from the outside memory, but I learned this from him, what he did as an editor, because when I got elected as the fellow of the academy, I think, they must have thought that one should get articles from all the young persons to write in the current science. So when got a ceremonial letter, please write an article for current science. And when I was not doing it, I was playing truant. Actually, he got his office to send me the letter 3 times before I actually submitted the article. I mean, this is, since we talked about his,
Yes,
you
yes.
know, as an editor, the kind of effort you put in, I mean, it's amazing. For me, it was a young person who was basically playing truant.
Yeah, I just have a memory. Ramaseshan used to like youngsters a lot. And he used to come to our chambers when I was working for current science. Instead of going, we meet, he used to come personally to our chamber. So that was his personality.
Can I interject something which I did plan to say about the NAL experience? From my description of the graduate school, you might get the impression that he outsourced everything to visitors. That is completely not true. And he would go around, and his standard question is very simple: what's new, right? And well, sometimes that was pushing us. He even told me when I joined, keep a diary, because all the things that you've done during the day and so on. And of course, sometimes he would call you to his office, and that was a strange experience because he would plonk you down on the sofa and pace up and down. It was very characteristic of him. It was completely the reverse of the research student standing in front of the guide who was sitting in the sofa, right? And I only wish I had learned that habit of pacing up and down. I had been a few kilograms lighter.
I'm not a scientist, but I knew him as a practical, down-to-earth scientist. He met me casually, and I told him the subject that I was working on, the products using asbestos fiber. Immediately his wind went off and said, Dorothy had done an electronic microscope on that. It was the most unique crystalline substance in nature. So can you give me a sample? So next day I went to NAL and gave the samples, and he repeated the studies. And he then took 3 projects from us, for which we paid him, and did fantastic work for my company, and we produced some fantastic results. Apart from this, I knew him personally, and I feel he always had his feet on the ground. He was not somewhere up as a scientist. He also had his feet on the ground. I always treasure my knowing him so well.
Yeah, thanks, Rajaram. And here.
Yeah.
Yeah. Just one observation, and Professor Ramaseshan, some people had the honor of distinguished visitors to RRI. Professor Ramaseshan used to take them to the museum and explain things and show them around. And it used to be a great time. At least I had one opportunity to go with him when Professor Rees was around. And it was a very, very interesting and exciting time when Professor Ramaseshan was in the museum. You know, you have something.
Okay, so thank you everyone. So we will thank Rajaram once again. May I request Tarun to hand over a memento to Rajaram.
Thank you, sir. I should especially thank you